Chemical reactions. Let us consider few processes occurring in our daily life and think what happens when souring of milk takes place during summers. An iron nail is left exposed to humid atmosphere. Coke is burnt in air. Copper containers get coated with a green film and turning brown of a freshly cut apple in air. In all these situations, the nature and the identity of the initial substance have somewhat changed and formed new substances. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. A chemical reaction represents a chemical change. The chemical substances originally or initially involved in a chemical reaction are called reactants, and the new chemical substances formed are called products. A plus B reactants give C plus D products. This means that identity of the reactants is lost and the new substance called product or products is formed. This also means that a chemical reaction involves breaking of bonds present in reactant molecules, forming new chemical bonds to give the products. This means that chemical reaction involves rearrangement of atoms. Let us perform an activity to understand chemical reaction. We clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. We clean it because the attack of moist air gives a coating of white layer of magnesium oxide on it. We hold it with a pair of tongs and burn it using a spirit lamp or burner. We observe that magnesium burns with a dazzling white flame and a white powder is formed that is collected in a watch glass. It is magnesium oxide. This means that magnesium combines with oxygen present in air to form magnesium oxide. So, we can say that a chemical reaction has taken place in which magnesium and oxygen are the reactants and magnesium oxide is the product. A word of caution. Burn the magnesium ribbon keeping it as far as possible from your eyes. Take lead nitrate solution in a clean test tube. It is colorless. To it, we add few drops of potassium iodide solution. What do we observe? Immediately, a yellow precipitate starts forming. After some time, the yellow precipitate settles at the bottom of the test tube. What do we conclude? A chemical reaction has taken place between the colorless lead nitrate solution and colorless potassium iodide solution to form a yellow precipitate of lead iodide which settles at the bottom. Lead iodide is the new substance and is called the product of the reaction. Lead nitrate reacts with potassium iodide to give lead iodide and potassium nitrate. In this chemical reaction, lead nitrate and potassium iodide are reactants, while lead iodide and potassium nitrate are products. If we take a few zinc granules in a conical flask and add dilute hydrochloric acid or sulfuric acid into it, we observe that from the surface of zinc pieces, a gas is evolved very briskly. Further, If we touch the flask, we find it to be hot. Next, we test the gas with a glass tube attached to the conical flask with the help of a cork. We then bring a burning splinter near the mouth of the glass tube. The burning splinter extinguishes with a pop sound. The gas evolved is hydrogen. Another substance formed is zinc sulfate, which we cannot see as it remains in the solution. Caution: handle the acid with care. A chemical reaction has taken place in which zinc reacts with sulfuric acid to form zinc sulfate and hydrogen. In this chemical reaction, zinc and sulfuric acid are reactants, while zinc sulfate and hydrogen are products. Rusting of iron. When articles made of iron are left exposed in air for a long time, a brown patch or layer appears on their surface. This is known as rust. We take few nails of iron in a test tube and add some water to it. Next, we close its mouth with a rubber cork. We then leave the tube undisturbed for a few days. A brown deposit appears on the surface of the nails. On analysis, it is found to be hydrated ferric oxide, that is, Fe2O3.xH2O, and that is formed as a result of chemical reaction which iron undergoes with water and oxygen. Oxygen is present in the empty space in air. Characteristics of chemical reactions. From the activities performed, we can observe the changes that take place in a chemical reaction are called characteristics of a chemical reaction. They can be in form of formation of a precipitate, evolution of a gas, change in state, change in color, or change in temperature. If any one of these changes is observed, the reaction is definitely a chemical reaction. Some chemical reactions are accompanied by formation of a precipitate. A precipitate is a solid substance formed on mixing two solutions. In the reaction between lead nitrate and potassium iodide solutions, a yellow precipitate of lead iodide appears. When silver nitrate solution is mixed with sodium chloride solution, a white precipitate of silver chloride is obtained. Or when barium chloride solution is mixed with sodium sulfate solution, a white precipitate of barium sulfate is obtained. Some chemical reactions are accompanied by evolution of a gas. In the reaction between zinc and dilute sulfuric acid, hydrogen gas is evolved. When calcium carbonate is heated, carbon dioxide gas is evolved. Some chemical changes are accompanied by change in color. Rust is brown in color, whereas iron is grayish-black in color. Lead nitrate and potassium iodide solutions are colorless, but on mixing the two, the precipitate of lead iodide formed is yellow in color. On adding oxalic acid to purple-colored potassium permanganate solution, the purple color disappears. Few reactions involve a change of state. Solid wax in the form of candle burns to form water vapor and carbon dioxide, which are gaseous. Chemical changes may also involve change in temperature, which can either be rise or fall of the temperature. Rise of the temperature occurs when the reaction is exothermic. When water is added to quicklime, that is CaO, taken in a beaker, slaked lime, that is CaOH whole twice, is formed, and the beaker gets heated up. On adding a small piece of sodium metal in a beaker containing water, it catches fire and solution becomes warm. Reactions in which heat is absorbed are called endothermic reactions. When barium hydroxide is added to ammonium chloride and is mixed with the glass rod, and on touching the bottom of the flask, it is found to be cooler. Barium hydroxide thus reacts with ammonium chloride to give barium chloride and ammonium hydroxide.